Now for question 25 of conic sections, there's again quite a bit of theory involved in this one. Maybe not just as much as 24, but hard to see where to get started with this one. First off, question is kind of worded a little bit off there. On the solution, the full wording is given, but F is one of the focal points, and I'll just underline now as I go. F is one of the focal points of a double hyperbola. A is a point on the opposite branch. Well, obviously B is a point on one branch, and then A is a point on the opposite branch. So basically there is a hyperbola each way, one catching B and one catching A. Not quite sure what they even looked like yet. It's not evident at all at the start of this question. The other piece of info that's given, the transverse axis is 50 millimeters long. So that's the other one. Part A, determine the position of the second focal point. So they're already aiming us in the right direction. They're telling us what they want us to do first. The position of the second focal point, and then draw a portion of it, and then determine the asymptotes. But it's that second focal point is the one that we need to start off by working with. Now, usually for these questions, what you might have both focal points and only one point in the curve. If you had both focal points and only one point in the curve, then you would join from the point in the curve to both focals. You would subtract your distances, just like we did last time. I know we had to work it a bit different there because of the tangent, but from a point in the curve, join to one focal and join to the other. Subtracted is the transverse. But this time they're working it differently. They're giving us one point and they're giving us one focal. They're telling us that this yellow line, the transverse, is 50. So there's a bit of thought involved in this. If there was a second focal point up here, then the line from focal to A minus A to this focal is 50. So the remaining line is 50, but the total length from the focal to A is 50 plus the length of this line. So if we can just take that one in for a second, let's start drawing, okay? I'm going to extend on that line, and I'm going to extend it by 50. So A to the first focal point, I'm going to take the line, extend it, and I'm going to add on 50 mil. That's plus 50 right there. I'm going to take that full size on my compass, and I'm going to swing it. Now, somewhere up along there, I assume, because I have so much space left on my page up there, somewhere up there is the second focal point. And again, I'll re-emphasize that in a few minutes. When we find it, we'll prove that we were right. So the line I want to draw here is 50 mil longer than this line, so that when I subtract them, my transverse axis remaining is 50. Working with my next one. There's a focal point. Let's just say it's there. The distance from the focal down to B and across to this focal, well, if I subtract one from the other, I want 50 to be left over. So it's kind of the opposite of the last time. So if I take the total distance here from B to the focal, and if I subtract 50 mil from it, so that's minus 50 this time. We were adding 50 last time. Now we're after subtracting 50 along here, and I'm going to take that distance and I'll swing it. That should be my focal point. I'm going to label it. I'm going to draw the axis, but then I'm going to go back and test just to make sure that everything is correct. That should be my focal point there, which means that that should be my axis. Let's test it out. From a focal point, joined onto point A, which is a point on the curve, and then joined onto the second focal. So from a focal point, joined to a point in the curve and joined to the second focal, if I subtract one focal line from the other, subtract this from here, I should be left with a distance of 50. And I am. Same rules apply on this for the second one. If I join the focal point to a point on the curve, and if I subtract that focal distance back down and subtract it here, I should be left with 50, and I am. So I've just used the theory that we learned at the very start, and you just use it and apply it in a kind of a backwards manner. So instead of using the 2 focals and 1 point in the curve, with 2 points in the curve, 1 focal and the transverse axis. Now the question is ready to really get stuck into it. Before I do, I might just, before I start drawing the curves, I'm going to go ahead and I'm going to find the center point. I'm going to draw the auxiliary circle and work with that. So bisect my focals to find the center of my question and the center of the auxiliary circle. So the bisector through the axis gives me a center point right here. The transverse axis is 25, radius 25 because it's diameter 50. I'm not going to go bisecting anything, I'm just going to mark 25. That means that I have a vertex and a vertex. Much like sheet 24, I can go ahead now and I can just drop in some points on the axis. So maybe just 3 points added in there, 10, 20, 30, 1, 2, 3. I might just do the same up this side. So vertex, I'm going to go all the way out to point 3. I'm going to start at the outside this time and work my way back in. Vertex to the point from the focus. And vertex to the point from the focus. Now, join those together. We see that we capture point A perfectly in this branch of the curve. Across to the other side, and that was 1, 2, 3, and I'll just call this 4, 5, and 6 across to the other side. So vertex, and I'll start out there at 6 in the focus. Vertex to 5 and vertex to 4, vertex to 6, vertex to 5, and vertex to 4. Now, so that's the 2 branches of the curve. So determine the position of the second focal point and draw a portion of the double curve. Done. Part B, determine the asymptotes to the curve. So this time we don't have the directrix. So what we can do instead is we have the auxiliary circle. We're going to take a line perpendicular to the axis through both vertices first of all. So I'll just set up some sliding set squares for this. So we'll go in line with the axis and perpendicular to the axis. So a line, let's do this with a colour. Set up a line perpendicular to the axis here and here. So there's our two lines through the vertices perpendicular to the axis. And last part of the process is we'll drop the compass in the center of the auxiliary circle, center of my drawing. I'll open up to the focal point and I will hit those pink lines. And I can do the same from this side, hit the pink lines both ways. So the points where they hit the pink lines, which is right here and here, will go perfectly through the center out the other side and give me the asymptote. And again, where is this one? It's here, through and down to here, through the center, touching. There's the asymptotes. So complex enough little question, two nice hard ones to finish off that set of worksheets. Hope these videos help. Thanks guys.